Chapter 4, Section 5, Isosceles and Equilateral Triangles. So the composition of this chapter is a lot of theorems, but they're theorems that are going to give you shortcuts when you're doing proofs. So just to talk a little bit about triangles. Well, first, these two pieces that are marked here would be considered the legs of the triangle, and this bottom piece would be considered the base of the triangle. This top angle is called the vertex angle. And because these two angles are on the base, these are called base angles. Here and here. They're not all congruent, just to denote the different types of angles. Now, Theorem 4.3 is the isosceles triangle theorem, and it states that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So the angle opposite this side is congruent to the angle opposite this side. A corollary to this theorem would be that if a triangle is equilateral, then the triangle is equiangular, which makes sense because if all three sides are congruent, then all three angles across from those sides are congruent. Now, Theorem 4.4 is the converse of the isosceles triangle theorem. So if two angles of a triangle are congruent, the sides opposite those angles are congruent. So this comes in handy if you're given two congruent angles instead of two congruent sides. And again, the corollary to this theorem, if a triangle is equiangular, that means the sides opposite all of those angles must be congruent, so it must also be equilateral. Theorem 4.5 says, if a line bisects the vertex, so we know that this is the vertex, of an isosceles triangle, so two sides are congruent, then the line is also a perpendicular bisector of the base. So basically, if this bisects the vertex angle into two congruent pieces, it also, every single time, is going to be the perpendicular and it's going to bisect the base. Every single time. So if it's an isosceles triangle and it bisects the vertex, that also means that it's the perpendicular bisector of the base.